Okay, now let's work another example concerning the inverse functions. So let's f be x cubed plus 2. So in this case, we see that the domain, so f is defined from R unto R. If we try and graph, and that's always helpful, if the function is too difficult, we can use a calculator. So this one is just the graph of x cubed shifted 2 units. So here, so I'm gonna do an approximation of this one. This is -1, this is -1.25. So this is 2. So this is approximation, okay? It's an approximation to see that our function is increasing, okay? So defined, and we can see that it can have an inverse function because it's increasing and it's surjective, okay? So we see that it's injective and it's increasing, and the y, the codomain is covered, whole of it, okay? So now we can prove two things, okay? So we're gonna prove that f is injective, okay, and f is surjective. To prove that f is injective, we assume that we have f of x is f of y, and we're gonna prove that x is y. So f of x equals f of y. These x and y are any real numbers. So f of x is x cubed plus 2. F of y is y cubed plus 2. We add -2 to both sides, and we take one of the variable to the other side, and we have x cubed minus y cubed is 0. This one gives us, after factoring, x minus y times x squared plus xy plus y squared is 0. Okay? So now we have this 0. That means x minus y is 0, or x squared plus xy plus y squared is 0. So this one is never 0. To see why, let's factor it out. So it's going to be x squared plus 2x times y over 2 plus y over 2 squared minus y over 2 squared plus y squared is 0. So it's x plus y over 2 squared plus 3 over 4y squared. This is bigger than 0 for all x and y except when both x and y are 0. So this is strictly bigger than 0, therefore it's never 0. So the only option is x. So the only option for x, these two to be equal, is that x is y. This proves that our function is injective. To prove that f is surjective, we can do two cases. So if x is bigger than 0, we have x cubed plus 2 is bigger than 2. So for the elements that are positive, they're gonna go to 2 plus infinity, and the elements that are negative, they're gonna go to x cubed is less than 0, so x cubed plus 2 is less than 2. So they go from 2 to minus infinity to 2. So the whole set is covered. That means f of r is r. This proves that f is surjective. Okay? Now, since f is surjective, we can talk about f inverse. So f is going from r unto r. For x, it does associate y, and g is gonna associate, for y is gonna associate x. So we have g of y is equal to x, or f inverse, okay, of y is equal to x. But we don't have so f inverse of y is x. We don't have a formula for f inverse. We are looking for that. We can use f to find that. So this means that we can switch back and forth between the two. Okay? So we have f of x is y. Okay? So now we solve for x in terms of y. So this gives x cubed plus 2 is y. So we try to solve for x and put it here. That's when we switch x to y. So this gives us x cubed is y minus 2, and therefore x is the cubed root of y minus 2. We switch back again when we put y as x here. So this gives us g of y is going to give us y, the cubed root of y minus 2. And we switch again back y to x. This gives us f inverse of x is just cubed root of x minus 2. Okay, so this is our inverse function. Okay, to graph it, okay, we can do that easily, but we are not going to do it because I don't have the tools with me now. So we can just do the symmetric with respect to y equals x. But basically, this is what we do. We check the domain. We see that we check where f is injective, where f is surjective. The issue here is that when we solve for x and y, we switch x and y's. When we solve for x, we switch back to x. Okay? And that's how we find the inverse function. Thank you very much. And if you have any questions or comments, please add it to the comments, like and subscribe and share. Or if you don't like it, that's fine for me too. Thank you.